In this video, you can solve one example for the Fourier series. So determine the Fourier series of f of x is equals to x square in the interval minus pi less than or equal to x less than or equals to pi. So solution, given f of x is equals to x square in the interval minus pi less than or equal to x less than or equals to pi. So here we can check whether the given function is either odd or even. To check that, replace x by minus x. F of minus x is equals to minus x whole square. That is, in the place of x, just we replace the value of x by minus x. Minus x whole square is x square. So we got the function f of x itself. So therefore, the given function f of x is even function. So if the function is even function, then from the properties of the integral, we can write bn is equals to 0. So we can write the value of bn as 0. We need to solve for a0 and an. So what is a Fourier series expansion? The Fourier series expansion, the Fourier series expansion of f of x is equals to a naught by 2 plus summation n runs from 1 to infinity a n into cos nx plus summation n runs from 1 to infinity bn into sin nx. So here, since the given function is even function, so we can write the value of bn will goes to 0, so that the sign terms will be disappeared. We need to compute only a naught and an. So where, what is a naught? So a naught is given by 2 by t. Integration runs from c to c plus t f of x into dx. So here what is the c and c plus t? This is the formula when function f of x is defined in c less than or equal to x less than or equals to c plus t. But in the given problem, the f of x is x square in the interval minus pi less than or equals to x less than or equal to pi. So the value of t is difference between the upper limit and the lower limit, that is pi minus of minus pi. So this is the value of 2 pi. T value is 2 pi. So we will get 2 divided by 2 pi, limits runs from minus pi to pi, f of x is x square into dx. Since 2 and 2 cancel, the function is even function, we can write the integral as 2 by pi. Minus pi to pi will change us to 0 to pi because 2 is multiplied here. So 2 integration runs from 0 to pi x square into dx. So again, the integration of x per n into dx is x per n plus 1 by n plus 1, provided n is not equal to minus 1. If n equal to minus 1, this formula doesn't hold. Means in that case, we need to integrate in the other way. 2 by pi. Integration of x square is x cubed by 3. Limits runs from 0 to pi. Now replace x by pi minus x by lower limit. So 2 is constant, 3 and pi is constant, 3 pi. So replace x by pi, so that is we get pi cube minus 0 cube is 0, so we'll get 2 pi cube divided by 3 pi, so 1 pi and pi cancel, we will get 2 pi square by 3. This is the value of a naught, but in the formula a naught by 2 is there, so you can compute the a naught by 2, so a naught by 2 is equals to pi square by 3, so we got the value of a naught by 2. Next is we required a n. For that formula is a n is equals to 2 by t, integration runs from c to c plus t, f of x into cos nx into dx. So which is equals to 2 by 2 pi, integration runs from minus pi to pi, f of x is x square into cos nx into dx. 2 and 2 gets cancelled. We will get 1 by pi. Minus pi to pi will become, from the properties of the integral, we can write it as 2 times integration runs from 0 to pi x square into cos nx into dx. So now we can apply the integration by parts. So by treating, so here it is a product of two functions. So one is a u and other one is a v. So we will apply the integration by parts. So what is that? Integration of u into v dx is equals to first function into integration of second function minus differentiation of first function into second term integration plus 2 times differentiation minus 3 times integration minus and so on. This is the Bernoulli's rule or integration by parts. We apply integration by parts repeatedly. So here u is taken as x square, v is cos nx. First function into, that is the x square into cos nx integration is sin nx by n minus differentiation of x square is 2x into integration of minus sin nx is minus cos nx, sorry, plus sin x is minus cos nx by n. Already n is there, so it will become n square. So here already n is there, so it will become n square plus differentiation of 2x is 2 minus is a minus, integration of cos is sin nx by n cube, so limits runs from 0 to pi. So now to apply the limits, we need to replace x by pi and x by 0. Here we have only sine and cosine terms, so first we can list out the few values. Sin nx value, if we replace x by pi, we will get sin n pi. So sin n pi is equals to 0. Next, if we replace x as 0, you will get sin 0. Sin 0 value is also 0. So next is cos nx is there. So here cos nx is there. If you replace x by pi, you will get cos n pi is equals to minus 1 whole per n, and the last one is cos 0 is equals to 1. These four values. So with the first value cos n pi, sorry, sin n pi equal to 0, the first term will goes to 0 and the third term also will goes to 0. We left with only the second term. So next, so here one minus is there, here other minus is there, minus into minus is plus. 2 is the constant, so this 2 can be taken outside. Means if we take 2 outside, we'll get already 1. 2 is there in the outside, so it will become 4 divided by pi. N square is further constant, take it as n square common here, this n square into replace x by pi, that is pi times cos n pi minus replace x as 0. So here x is there, we need to replace its value by 0. So if you observe here x is there, we need to replace its value by lower limit, that is 0. In that case we'll get 0 into cos n into 0 is 0. So in this, since cos 0 is 1, sin 0 is there, so 0 into 1 is equals to 0. Here, so pi is there into cos n pi. So pi into cos n pi is minus 1 per n. We can replace this term by pi into minus 1 per n. So we'll get 4 by pi n square into pi times minus 1 whole per n. So here multiplied by divided by gets cancel, we'll get pi cancel, 4 times minus 1 whole per n by n square. So this is the value of an. So an is equals to minus 1 whole per n, 4 times divided by n square is the value of an. So since the given function is even function, so what is the nature of the given function? Given function is even function, so there is no need to compute the value of bn. We need not to compute the value of bn. Directly we can write the value of bn as 0. So this is true only if f is even. So with that property, directly we can take the value of bn as 0 because f is even. With this we can write, therefore the Fourier series of f of x is equals to x square in the interval minus pi less than or equal to x less than or equal to pi is given by f of x is equals to a naught by 2. It is computed, we got it as pi square by 3 plus summation n runs from 1 to infinity an. The value of an is 4 times minus 1 whole per n divided by n square into cos nx. So here, if f of x is even function, Fourier series consists or contains only cosine terms. So it consists only cosine terms if the given function is even function. Thank you.